Middleware, the code that runs before your handler. Today we look at what it is, how it wraps your code instead of queuing in front of it, and why the order you list these steps in is not a detail. It is the configuration of your service.
Here is a real service. It grew to 40 endpoints. 3 things had to happen on nearly every one of them. Check that the caller sent a valid token, write 1 log line, start a timer, and stop it again. So somebody wrote those lines once and then pasted them into endpoint after endpoint by hand. It worked. For a long time, it worked fine. Then somebody added endpoint 41. They did the sensible thing. They opened the endpoint next to it, copied its shape, and changed the parts that were different. And they missed 1 line, the token check. That endpoint went to production and answered every request without ever asking who was calling. Nothing errored, no test failed. So here is the question this whole video is really about. Why did nothing tell them?
The subject is middleware, and 3 things I want you to walk away with. First, the code that runs before your code. There is already a stack of it between the network and your function, and middleware is how you add your own step to it. Second, the shape. A chain of middleware is an onion, not a queue. Each step wraps the next one, so each step gets a turn on the way in and another on the way back out, and any step can refuse to go on. Third, and this is the one people miss, the order is the product. What this is not a tutorial for one framework, because the shape is the same everywhere, not about how you split the code inside your handler, and not a security video. Where does it bite? In the rule you had to remember 40 times. In the morning, every endpoint broke at once, and in the rate limit that quietly protected the wrong people.
Before any code, one picture, because the wrong picture is what makes this hard. Most people imagine a chain of steps as a row of gates, 3 gates standing in a line. You walk through the first, and it is finished with you. Nothing wraps anything, and on the way back out, you meet none of them again. That picture is wrong, and every confusing thing about middleware comes from it. Here is the right one. 1 building, cut open from above. 3 walls, one inside the other, with a single door through each. To reach the desk in the middle, you pass through every wall, and to leave, you pass through all of them again in the opposite order. Now ask both pictures the same 3 questions. Can a step do something after your work is done? A row of gates? No. Nested walls? Yes. Can one step stop everything behind it? Gates? No. Walls? Yes. And who knows how long the whole visit took? In a row of gates? Nobody. In nested walls, the outer wall, because it saw you arrive and it saw you leave.
Now, one level below the word middleware, your handler is not the first code that runs. Think about what actually happens. Bytes arrive on a socket. At that moment, there is no request. There is a pile of bytes. Something has to read them, find where the headers stop and the body starts, and turn that into an object you can ask questions of. Then something else looks at the path and the method and decides which of your functions should deal with it. Only then does the first line you wrote run. You did not write any of that, and it runs on every single request. So the real question is not what is middleware. It is this. There is already a stack of code in front of your handler. How do you put your own step into it without editing every handler by hand?
So let me show you the thing all the numbers in this video came off. It is one small service, 6 endpoints that do real work, plus a health check. It has a catalog in a small database, and it runs as one process on one port. It is written on one of the usual web frameworks, and I want to say clearly that the name does not matter, because the shape is the same in Express, in Django, and in ASP.NET. What matters is this line here: errors, then request ID, then log and timer, then off, then rate limit, and then your handler. That is the chain this service is configured with, and it is the same order for the whole video. Nothing here is a sketch. Everything I put on screen from now on was measured on this.
First, how this looks before anyone has heard the word middleware. Here is 1 endpoint. 2 lines to find out who is calling and refuse them if the answer is nobody. 1 line to start a clock, 1 line to write a log line, and 1 line at the end to record how long it took. 5 of the 6 endpoints look exactly like this, and here is the 6th, added last. It has the clock, it has the log line, it has the timer. It does not have the 2 off lines. That is the whole bug. Not a clever bug, not a race condition. Somebody copied an endpoint and stopped 1 line early. So let us count it.
Across those 6 endpoints, there are 50 lines of auth, logging, and timing sitting inside the endpoint functions, 9 in each of 5 of them and 5 in the 6th, which is short because 2 lines are missing. I counted the statements a second way with a separate tool and got 51, so the number is real. Write those same 3 concerns once each as steps, and the number of lines left inside the endpoints is 0. And one endpoint of 6 shipped with no token check, because a human had to remember it 40 times and remembered it 39. Now, one honest thing, because I nearly put the wrong number on screen. The endpoint file does shrink from 92 lines to 52, but the steps themselves are another 137 lines. So at 6 endpoints, the whole repository is not smaller. What you bought is not less code. It is one place where the rule lives. So here is the answer, and it is smaller than you expect. A middleware is a function handed 2 things, the request and the next thing to call. That second argument is the whole idea. Look at what it lets you write. Line 1 runs before anything else and starts a clock. Line 2 calls the next thing. Line 3 runs after, stops the clock, and writes the number onto the response. Before, handed on, after. Every middleware you will ever read is that shape. The line that surprises people is the middle one. It does not finish and pass the request along like a relay. It waits. Your code sleeps on that line while everything deeper runs, including your handler, and wakes up when a response comes back. That is exactly why line 3 can know how long the whole rest of the request took.
So let us draw the real thing. 5 steps in the order this service is configured with. Errors on the outside, then request ID, then log and timer, then auth, then rate limit, and your handler in the middle. Notice how they are drawn, not side by side, one inside the other. Errors is outermost, so it is the first step a request meets, and everything else is inside it. Rate limit is innermost, so it is the last thing before your code, and your handler sits in the center, the only thing here that knows nothing about the rest. A request comes in from the left and works its way inward, one wall at a time, each step calling the next. One thing worth saying out loud, because it is a different topic. The chain ends where your handler begins.
So let me prove the shape rather than draw it again. Every step in this chain prints a line when it is entered and another line when it is left. Here is one authenticated request. Errors, request ID, log and timer, auth, rate limit, and then the handler runs. And then look what comes back. Rate limit, auth, log and timer, request ID, errors. 5 steps in, 5 steps out. And the way out is exactly the way in reversed. The program checked that itself, and it says true. That is not a convention somebody agreed on. That is just what wrapping means. If errors is on the outside, then errors is the first thing entered and the last thing left, and there is no arrangement where that is not the case. Now the half of this that almost nobody draws, your handler returns a response, and that response travels back out through every wall it came in through. So every step runs twice, once going in, once coming back. Look at what each does on the way out. Rate limit records that this request counted. Auth has nothing left to do. The timer stops the clock and writes its line. Request ID puts the ID onto the response. And errors, on the outside, is the last thing to touch it before it leaves. Here is the consequence. The first step in is the last step out, so the outermost step is the only one present for the entire request. I measured that. The outermost step saw 68 microseconds. A step wrapped directly around the handler saw 34. The handler is just under half of what the outside sees, and that gap is the rest of the chain. Now the third thing a step can do, and it is the one that makes the chain worth having, a step can simply not call the next thing. Here is a request with no token. Errors runs. Request ID runs. The timer starts. Auth looks at the token, does not find a user, and returns a 401 straight away. And now look at what is dark. Rate limit never ran. Your handler never ran. Not because they decided not to, because nobody called them. I sent 50 of these. Auth ran 50 times. The rate limiter ran 0 times. The handler ran 0 times. And this is not the chain failing. This is the chain doing the exact job it was put there for. And here is that step, in full. It is 4 lines. If the token is not valid, return a 401. Notice what is not on that line. There is no call to the next thing. That is the entire mechanism. If you never call it, it never runs, and everything wrapped inside it never runs either. Only a valid caller reaches the last line, the one that does call the next thing. And here are the counters from the running service. Auth reached, 50. Rate limit reached, 0. Your handler reached, 0. 50 responses, all 401. Your handler did not decide to refuse those. Your handler was never asked. If you have ever wondered why a browser preflight request never shows up in your code, this is why. It is the same move.
Now the part I actually want you to remember. Take 2 steps, auth and a rate limiter. Put them in the 2 possible orders. Both versions run. Both are configured correctly. They do different things. Put the rate limiter on the outside, and every request that arrives gets counted before anybody knows who sent it. That is good because the flood of junk is stopped before it ever reaches the auth check. But it is counting by address because nobody has been identified yet, so everybody behind one address shares one budget. Put auth on the outside instead, and every request is identified first and only then counted. So the limit is per user, which is almost always the limit you actually meant. But now the auth check runs on every piece of junk that arrives and pays for all of it. So which one is right? That is the wrong question. Neither is wrong. They are 2 different products.
And here is where that decision physically lives. It is a list, 1 line apart. I sent the same 90 requests at both versions, 30 from one heavy user, 30 from 30 different users, and 30 with no token at all. With auth on the outside, the auth check ran 90 times, and the rate limiter saw 60. With the limiter on the outside, the auth check ran 10 times. It was protected, exactly as advertised. Now the part that matters. Look at who got turned away. With auth outside, 20 refusals, and every one of them went to the one heavy user. The 30 separate users got 0. With the limiter outside, 27 of those 30 separate users were throttled. They had done nothing. They just happened to arrive from the same address. And notice, every status code here is a normal one. Nothing in this output tells you which of the 2 you meant.
That is not a special case about rate limiting. It is the whole rule, and here it is twice more. Register the request ID step last, and only one of the 4 log lines carries an ID because the other 3 ran before the ID existed. Register it first, and all 4 carry the same ID. Second, put the error catcher on the inside, and when a step above it fails, the failure goes straight past it. I measured that. The caller got no response at all, just an unhandled error. Move the same catcher to the outside, and the same failure comes back as a clean 500 with a JSON body. Same code, same bug, different position. So here is the rule you can actually use. Anything that has to see everything, including the failures, goes furthest out. Anything that needs a decision somebody else already made goes inside the step that makes it.
So let us be honest about the bill. What you get is real. The rule is written once and applied to everything, and a new endpoint is protected on the day it is written, by nobody. 6 endpoints of 6 now refuse an unauthenticated caller, including the one nobody remembered. Now what it costs. First, it is invisible from inside the handler. I changed 1 character in 1 step, and all 6 endpoints started returning 401 to a perfectly valid credential. The handler files were untouched, byte for byte. The symptom is everything is broken, and the cause is 1 character in a file you were not looking at. Second, and this is the worst one, a wrong order is completely silent. 0 exceptions, 0 error logs, 0 500s. Third, every request pays for every step. A step that reads the database added 17 microseconds to a health check that needed none of it. And fourth, your handler cannot count what never reached it. Of 160 requests, it counted 50. So what do you do with this? If something has to happen on every request, it does not belong inside a handler. Not in 1, and definitely not pasted into 40. Write it once as a step and register it. Then do the part people skip. Read the list from the top down and say out loud what each step wraps. Errors wraps everything. Request ID wraps the logging, so every log line has an ID. Auth wraps the limiter, so the limiter can count by user. If you can say that about your own service and it sounds boring, you have got it right. And when you add a step, decide where it goes on purpose. Outside if it has to see everything. Inside if it needs a decision something else already made. A cross-cutting concern is not something you remember 40 times. It is a list, in one place, in an order you chose.
If this comes up in an interview,
3 questions and what a good answer sounds like. What is middleware, in one sentence? Code that runs around every request. It is handed the request and the next thing to call, so it can act before, act after, or refuse to go on at all, and it is registered once instead of written into every endpoint. Why does the order matter? Because each step wraps the ones below it. Auth before rate limiting means you limit users. Rate limiting before auth means you protect the auth check itself. What is the downside? This is the one that separates answers. The chain is invisible from inside the handler, so one broken step looks like every endpoint breaking at once. Every request pays for every step, including the health check that needs none of them. And the strongest thing you can say is the last one. A wrong order raises no error. Nothing breaks. Nobody finds out until the wrong people are being throttled.
So the whole thing as one chain. You are not first. Code you did not write already runs before your handler on every request, which is why you can add your own step to it, a function that is given the request and the next thing to call, which means it wraps. It does not queue. It runs before, it hands the request on, it runs again after, and it may simply refuse to go on, and therefore the order is the product. What wraps what decides what your service actually does, all of it at one price. A wrong order raises no exception, writes no error log, and tells nobody. So the habit is simple. Read the list from the top and say out loud what each step wraps.
Thanks for watching. If that made the chain make sense, hit like and subscribe so the next one finds you.